Let's get started. Tonight I have even less of an idea of what I'm doing than usual. I read on Twitter that the pattern matching PEP was implementation was merged like yesterday or today or something, and I don't really know a lot about it. So my plan was to read the tutorial a tiny bit and look at that and sort of try to use the new pattern matching stuff to do something compiler related. Right. So here's PEP 636, and it's titled Structural Pattern Matching Tutorial, and it has all kinds of things that I scrolled through earlier. And the basic approach seems to be that you have this new match command, and then you say what you want to match, like what the object that you want to match against the cases, and then you have a list of cases. Hi EW Joachim. Right, and the cases basically perform some sort of complicated destructuring on the object that is produced here. Right, and so here we produce some kind of object, and then the various cases try to deeply deconstruct it against the things that are given here. So here it would match if it's a list of the string quit. Here it's a list of the string look. Here it's a list of two elements, get an object, and then here it's go. And the second one isn't actually something that imposes an extra constraint on the object up here. Instead, it binds the second element of the list to the variable direction. And I mean, as I said, I really don't know what I'm doing. So what I'm going to try first is to simply try some of the very simple examples, but then I want to get to a place where I understand the examples that involve objects a little bit more, because I think those are for me those are the most interesting somehow. Yeah. Can somebody on the chat tell me whether you can hear me okay and see me okay? Because I've changed my setup a little bit, and if there's something particularly weird, let me know, and then maybe I can fix it. Can you hear me okay? Right. Let's first make sure that I actually managed to make a virtual env with the new Python version that actually has the feature. So if we say something like we have a ABC, wonderful, thanks for the confirmation. So, and let's see whether we actually have the feature. So if we say match X, and then we have a case ABC, print case 1, case underscore is the fallback case that matches anything. Fallback. And if we understand this correctly, then we should hit the first case, because X is the string ABC, and it matches against the pattern ABC, and so we should execute this thing and not this thing. Let's try. Right. Okay. So I managed to install the Python. Okay. So that's great. So the thing that I don't quite understand is how how this pattern matching thing works against instances. Hi execCZ. Nice of you to join us. So further down, okay, there's all kinds of stuff like or patterns. You can say I want it to match against that or that. You can have sub patterns, so you can have a list with the first element go and the second element is a nested pattern. north, south, or east or west, right? That makes sense. And you can also use as to give something a name that you want to impose a structure on, right? And then you can also add an actual if after the case where you give some actual Python code that that produces a bool that also needs to be true, right? Okay, and what I'm particularly interested in, as I said, is I wanna find out how you use this feature to match against objects, right? Okay. And the syntax seems to be that if you want to match against a class called click, it says it's using isInstance, and then you can just give the class name here, and then in parentheses you can give constraints on attributes of the objects. Right. Yeah, somebody on the chat says I should look at the feature pep too. I mean, I actually like the tutorial pep, but it's probably good. It's good to have it open as a fallback if we need to understand something that's more complicated. Right. Where is it? Sequence patterns, class patterns. Right. Right. Okay. Okay, that's good to know. Right, but you can match classes by having round parents, and then you can give, with a keyword argument like syntax, you can give constraints on the fields of the instance. Right, so let's try that. Maybe I should actually start using a file because right, so if I make an instance 1, 2, then, and I have a match, right, Vim of course doesn't know about match yet. Match A, and I say case A equal A, B equal B. This is a bit weird. Print A, B. Hi Tobias, good to see you. Yeah, I have a new setup. Let's see how it works. Right, and then case B, A equal A, B equal B, print A, B. Let's make a second class that looks the same. Right. And here we expect to be in the first case. And this weird syntax here, which I find slightly confusing, means that we want the instance to have a field A, and we want to match that against the pattern A. And the pattern, if the pattern is just a name, then it doesn't have actually any constraints. It will instead bind it to a new name A. Right. So let's try that. Right. So, and indeed, if we have this instance A here, we end up in this case, and we deconstruct it and reading the two things out. Yeah, so EW Joachim says, what happens if you have two patterns that have the same name? I mean, is it just left to right? Is it forbidden? Right, it's forbidden. That's good. Right, I'm actually also worried about these kind of corner cases. Like, I think the one corner case that was discussed a little bit on the mailing list. No, yeah, it wasn't overwritten. It was really it gave an error. It really said you cannot have multiple right-hand sides, like multiple patterns that assign to the same name. that makes sense. Right, but there's another interesting case. What happens if we have something like, so we want to make sure that A is 2 and B, no wait, A is A and B is 5, right? Then we print it, and then we have a fallback case that works in any case, haha. And then fallback. And my question is now, is the variable A, no, I shouldn't. Okay, I think I see what you meant on the chat now. This A here is overwritten, right? This A here, by the A that I use here. Okay, so this is better. So, yeah, as you can see, I'm still slightly confused by this feature. So what this means is, I want to match against an instance of A that has a field A that I bind to X, and a field B that needs to be equal to 5. And then I print A and X. And then if that doesn't match, and it doesn't match here, my question is the name X, does X now have a value or not? Right? Because while it was pattern matching this line, it already checked, I assume that it goes left to right. So it already checked the first part of the pattern and found out that it matches, and it probably means, I mean, one implementation strategy would be that it already assigns a value X. And then only on the second field, it recognizes that the object doesn't match, and then it cannot go into this case. So it sort of needs to consider the next case. And my question is, can we observe the failed pattern match attempt of the first case here? Let's try. Right. Indeed. And yeah, I think that is indeed one of the critiques here, I think. Right. So Olukrio asks, hi by the way, what happens when the class A has no field named A at the time of matching? Yeah, that's a great question. So let's actually let's make a new class for that. What happens if we have a class C and an instance, and then we try to match C, and we say we want a field A that is equal to 1, right? What happens then? Does it give an attribute error, or does it just swallow the exception and say it doesn't match? Right. Okay. So what happens is that we end up in the fallback case, but we had a typo. So so it indeed means if there is no field A, we will really just ignore the case. But that makes some kind of sense. Right. So the other thing that I'm not entirely sure about is, what about subclassing? So if I have a subclass D that matches, and let's just say, wait, no, wait. My experiment is wrong, because I'm still matching A here. I need to match C, of course, because A obviously doesn't even match C because, right, because A doesn't match C because it's a different class. So let's try this actually, right? But the same happens. EW Joachim says there's something strange in that the pattern matching kind of pushes us to think that the class constructor matches the class structure. If there's an A param in the construction, then there's a self.A. Yeah, that's true. I mean, this definitely looks like a constructor call, but it's really not even close to a constructor call. Right. Okay. Yeah. The other corner case that I'm not entirely sure about yet is what happens if we actually make a subclass, and then we have D equal to D, and D actually has an A equal 1. Does it match? Right. No, C. I mean, I think the tutorial says it's using isInstance, So that would mean that we want to end up in this case here. Did I save? No, I didn't. That's surprising. I still have C here. Sorry. The second time I made that error. Okay. Right. But it works. Right. So it really uses isInstance to figure out that we want to end up in that case. So the question is, what if we have a generic thing here, specific value of a dot equal 1? Yes, I think it would match. I mean, we did that earlier, but this really means I want this instance to have an attribute A, and I want to bind the value of that attribute A against to the name X. So this, I mean, if a pattern is really just a variable name, it doesn't mean it needs to have a specific value. It really means please bind it to this name, right? And then we can actually use X. Right. No, I think it's actually, I mean, it's actually good to redo this part, because in some sense this is really the strangest part, right? I mean, this fact that you have a pattern here, and I mean, this doesn't look like, this is really doing something entirely different than you writing A equal to X like this, right? It's because it's really not a constructor call at all. It's really, it's a class pattern that says, I want an attribute A, and please bind it to X. Right? So yeah, I'm confused. I'm getting. I'm still matching on D if you matched on C with no C.A. Right, like this. I think that will fail because there is no A. There is no field A. Right, so we end up in fallback. The other comment was, how does it work with args versus keyword args? If you match without specific arguments, right? Yeah, I think that's the next part of the tutorial that we didn't read yet, matching positional arguments, and you can use it for data classes, and then it's just the order that the attributes are defined. But I'm not interested in data classes, and I think if you want to have this for your own classes, then you need to have this special attribute that really says, please match me in that order. No worries, Olucrio. I think it's good that we're going through this stuff, because I really think, I mean, I've been using it for all of 20 minutes, but it really feels like a little bit of a departure from what Python normally does, right? Actually, let me clean up a little bit, like this, and so A and B, right? And what you do, this special attribute means if you want to match instances of that class without this keyword argument syntax, you can now say A, B, right? And that actually is now we're back at a relatively natural syntax. So if we now I 1, 2, and then if we match against that, then we see, okay, it matches. Oops. It matches because it's an instance of A, and we will extract the match args in order, and that means first we match the attribute A, and we match it against the pattern A that binds the value of the attribute A to A, and binds the value, and then we continue with the second thing, and that's B, and that means pattern B, and that means we bind the value of the attribute B to the name B, and that makes some kind of sense. Right, and actually let's rename those things to make it clear that it's really not, I mean, it's really a coincidence that we gave them the same names. We can use completely different names too. Right. Okay, and now we can also use the same syntax for saying, okay, 1. And that will not match, right? That will not match that one because we have a 2 there. Let's try. Right. If we write a 1 there, then we should match. Right. And I think I think it gets interesting if we really have more complicated patterns after we've gotten used to this kind of syntax. So let's try. Let's actually make a weird A that has another, maybe it has a B. 5. Right. And then we have a class B with match args. Yeah, this example is extremely artificial now. I think I have a cunning plan to try a somewhat more useful example in like 5 minutes, but I wanna sort of test out the corner cases of this stuff for a little bit longer. So now if we have a pattern that says, okay, we can leave that. If we have a pattern that says y, right? I mean, that's kind of the fun thing, I think. Right. Because now the second field of the A instance is matched against the B field is matched against the second pattern B, and the B pattern means I want an instance of B here, and the fields 1 in the match args, which is the field C, should be bound to the name Y, and that means we will extract the numbers 1 and 4 here. Right, it works. Yes, I mean, I'm not really sure. I mean, to me, it really looks like Prolog. It's very strange because Python is usually Python is not Prolog, but I mean, this is very close to what you would write in Prolog actually. So that, I mean, if I think about it as Prolog code, it feels okay to me. But yeah, as I said, Python is usually not Prolog, so it takes some getting used to. Okay, actually, my plan is that I mean, this kind of pattern matching is actually most fun if you really have some kind of tree-like data structure. And of course, I'm working on compilers usually, so my plan is now to write a tiny optimizer that sort of walks a tree of operations and sort of does some very simple local optimizations and I want to try and see whether it's fun to express that with the match statement. I mean, this is completely unplanned. It might not actually be cool, but I want to try it because I mean, so the typical pattern matching languages like Prolog or Haskell or ML or something, they're really meant to be used for interpreters and compilers and stuff where you match on complicated tree data structures. And so I think it makes sense to try to apply it to an example where it would be a natural language construct to use and not something else. So XXCZ asks, how does PyPy plan to represent matches, convert them to regular conditions, switch statements, or add new opcodes? Oh yeah, actually, before I delete all that stuff, that's a great question. And I think, I mean, so how we plan to do that in PyPy, I actually have no idea yet, because we're very far from 3.10, right? I mean, I'm currently catching up with 3.8, so and then I need to go and finish that or finish that more, and then we get to 3.9, and then only then we get to the pattern matching stuff. So we're still probably at least a year off, maybe 1.5 years. But our usual strategy is actually to follow what CPython does very closely. But what I don't know is how CPython actually does it. So maybe another useful thing we can do is we can explore what CPython compiles this to, right? So let's actually look at the bytecode for this function. Thanks for reminding me, because I kind of wanted to have done that anyway. Right. So what's not clear to me is, are there any new bytecodes, or is it just completely compiled down to the existing bytecodes? Okay, so here we make A, right? And then this is the match, right? That's line 17. Does that? Oh, what are the line numbers? I'm not sure. And anyway, let's look. So we load A, that's the thing that we want to match against. And then we have the first case. And the first case says we load A, and then we load const parents. Why do we load parents? So I don't know what those parents are for. Maybe it means we don't have keyword arguments. Right, and then we have a match class. That's a new bytecode. Okay, interesting. Let me actually grab for that bytecode in the CPython source code. Right. There's documentation. Excellent. Right, so that seems there are all kinds of new match bytecodes. Right. Match keys, match sequence, match keys, match class. Top of stack is a tuple of keyword argument names, right? That's what I guessed. We don't have keyword arguments here. TOS1 is the class being matched against, and TOS2 is the match object. Count is the number of positional subpatterns. Pop TOS. If TOS2 is an instance of TOS1 and has the positional and keyword arguments required by count and TOS, set TOS to true and top of stack 1 to a tuple of extracted attributes. Otherwise, set TOS to false, right? So what match class does is it will either leave a true or a false on the top of the stack, right? And then we have a pop jump if false. So that means the pattern didn't work, jump to 52 to continue with the next pattern, and this is where 52 is, right? And so if we're matching, then the next step is we need to match the subpatterns here, and for that, match class left a two tuple on the stack for us, right? So, right, and that's what the binary subscore is for. We read the first element of the extracted attributes and store it to X, right? Because the first pattern is just give it a name X. And then we do the second, then we look at the second element of the tuple, which is matches against 1. So we have we read the second element here with the binary subscore, then we read the 1, and then we have a compare op equal, and a pop jump if false, where we jump to the second case if they're different, right? And if they're not different, then we jump forward to 65, which is here, and then we go to, then we end up in the first case. That's the first case here. The first case says print stuff. Okay, it's a little bit. I mean, it's a lot of bytecode, right? I mean, so for each of the this thing here is matching the first case, and then we have the body of the case. This thing here is even longer. It's matching the second case. It should have two match classes. There's one match class for A and another match class for the sub pattern for B, right? And then we have the body here, the print stuff. And then we have the third pattern here. It's a bit shorter because it just assigns names X and Y. And then the body. And then we have the fallback. And the fallback, it really does no matching. It just prints stuff. Okay. Okay, so now we learned, that's interesting. I really had no clue how it works. But now we learned that CPython compiles it down to relatively normal looking bytecodes, except for these new match bytecodes. And the match things. Let's actually look for version added. Right. So match class is added. Copy dict without keys. What's that for? Get lang, match mapping, match sequence, match keys, and match class. Right. So there are 4 new bytecodes, and then 2 strange ones: get len and copy dict without keys. That also seems to be about mapping. Replace top of stack with a class dict with a dict formed from the items of TOS1 without any of the keys in TOS. Interesting. Okay, I don't completely know what that is for. Yeah, I suppose it's if you match a dictionary and you want, yeah, let's actually look at the full PEP. I kind of suspect, right. The copy dict without keys thing is for a mapping pattern where you have a star star rest. Right. Good. And that means you need to remove all the things that you explicitly matched, and you want to have only the remaining keys. And that's what this weird new bytecode is for. That copy dict without keys that takes a dict and copies it and then removes a few keys that are given. Right. Okay, so now we understand how CPython does it, and PyPy does it the same way. I mean, as I said, we're not there yet. PyPy will get there in many months. But when we get there, our usual strategy is that we follow what CPython is doing quite exactly. So I suspect we will do the same thing. So XXCZ has now decloaked, and I assume you look, and yeah, not really. I mean, the JIT backends don't really have to do any of that stuff. I mean, for the JIT backend, that's completely done in the front end. So the interpreter will deal with all of that stuff, and we don't really have to deal with any of these weird features in the JIT. That's kind of the idea of the JIT. The JIT will really just do what the interpreter does, and there's no need for new features in any of the JIT backends. Right. Okay. So what I want to do now is I want to use, as I kind of warned you, I want to try and use this feature for basically a small AST optimizer. And it's really going to be tiny, but I'm interested in trying to see whether people always tell me that pattern matching is good for AST, so now I want to try it against an AST thing. And so let's write a very small amount of classes that represents sort of trees of operations, or maybe DAGs, like directed acyclic graphs of operations. So self, left, right, left, right. Maybe I should use data classes. Match args equal left, right. Okay, so there's add. Maybe I should have an abstract base class. Oops. And then we want a sub, but the sub looks the same, so maybe I actually have another abstract class called binary. Then I can have 2 subclasses of that. Add binary pass class sub binary pass, right? Okay, and I mean, then we need something like a variable base, and then maybe a constant. and equal value, match args equal name. That's actually enough. I don't want more. I mean, the plan is that what I want to do, let's write a test. Test const fold, for example. So let's say we have an AST that looks like this. We have an add, and we add a const 1 and a const 2, right? And that then we have some optimize function, and optimized, optimize, we want this to look like this instance res const and res.value equal 3, right? I mean, that's the kind of stuff we want to do. We want to write an optimize function that's just one gigantic match statement, and that should sort of do all kinds of simple optimizations. Let's try that. Def opt x case no match x. So the first case that we're optimizing here is case add const x const y, right? And then that is return const x plus y. And then the fallback case is return x. Case. I mean, the fallback is we don't optimize at all. Right. Okay, this looks like nice. This looks very prologue-y. Hi Ethan, nice of you to join us. Right. Yeah, we're playing around with the match statement, and we don't completely know. I mean, I don't completely know what I'm doing, but since you just joined, we played around with sort of the semantics a little bit, and now the plan is to try to use it. I mean, it's supposed to be good for matching trees, so I'm trying to apply it to a tiny optimizer that makes ASTs with these small amount of classes more efficient. And we just added a constant folding optimization. Actually, let's add one for sub 2. Right. Sub. And then we want -1. Right. That shouldn't work at this point. Right. Because it doesn't work because we use the fallback case instead. So we need to add a case here that says, okay, if you have a sub with 2 constants as arguments, and then you want to return the subtraction. I mean, so far we've actually written an interpreter for the AST, right? I mean, this interprets the AST and turns it into a value. But we will soon have cases that are not like that. Right. Good. This passes. Okay, let's add a real optimization. Sub xx. So if we do something like sub let's define a variable. X. And then we want to say assert is instance res is a const and res.value equals 0. Right? If we subtract one thing from itself, then we want to get 0 out. How Ethan says audio and video is not in sync. Yeah, I switched to a new setup and I'm still getting the chinks out. Is it unbearable, or can you deal with it by just not looking at my face? if it's completely unbearable, I might have to stop preview, or I probably won't stop, and we'll just fix it until next week. Right. So now we need a case that deals with that. Yeah, I promise that I'm going to improve this problem. But I definitely know that my camera is lagging for a couple of milliseconds, and it's possible that I didn't quite get the lag completely right. Right. So, I mean, in Prolog I would want to write this, right? But I think that's a syntax error. And this is kind of what I want to write. I want to say, if I have a sub and the two fields of the sub are the same thing, then I should just return a 0. But I think that syntax is forbidden. Right. Syntax error. Multiple assignments to name X in pattern. Because it's really not like a Prolog match statement. So let's actually say something like if X is Y. Right. So if the two arms of the sub are the same thing, then we can turn it into a 0. Right, good. Kind of cool. This doesn't look too bad. Right. What else is there? If we, real compilers have really complicated cases. Let's actually try. Like if we have something like a plus x minus x, we want it to turn it into a. So let's try that. Add a sub. Oh, no, wait, that's not what I want. Let's see, I want it like this, right? So it should be xy, and then afterwards I do the sub, right? And that should turn res is a. Okay. Fails, great. We need to add a case for that, and it's another sub case. It's a case sub of add a b c. I again want to write this, but I can't. But now I want to say that if b is c. And then we return a. Right. Cool. Yeah, that's not bad. Let's add one more case to get a kind of feel for it. Hi Julian, good to see you again. How are you doing? You can tell me how badly my audio and video are out of sync. There's a divided opinion in the chat. Right, what other case do I want to add? Another somewhat interesting case is that Sometimes constant folding. 4 out of 10. Okay, that could be worse. Right. If you have something like this, you have a const here, const x, plus a const y. Then the constant folding we have so far will not solve it, right? Because this thing isn't constant foldable because the two things aren't consts, and this one is also not constant foldable because they aren't consts. So if we say res opt, what we want to turn this into a plus const x plus const y, and then this is really the sum of the constants. So this should be nicely expressible. So add a and const 5 and const 7, and then we want to say assert res. What is the instance? Res is an add, and res dot left is a, and res dot right dot value is 12. Right. Let's see. Can we write this easily? So the pattern, it's kind of fun. I mean, what I like here is that we write this test, and then we can basically copy the test and turn our example into a case, right? So we say case, and then of course it's not the constants, it's x and y, but we return add now it's a and const x plus y. Right. Actually, before I add that, let me make sure that let me prove that the current constant folding doesn't deal with the new test. Right, it can't. So, and then this code kind of maybe does it. Right. Yeah, so I mean, I'm definitely open for comments. This whether people like this thing or not. I mean, it's definitely very dense, right? So it's a very concise way of writing down these kind of patterns. I mean, of course, I picked an example that is sort of the perfect match for the new language feature. So I'm not really sure whether we're definitely not learning the downsides here. I mean, we're using it for something that it's really kind of made for, and I think so far I kind of like it. It's it gives this very dense code. I mean, it's not like you kind of need to carefully study each of these cases to make sure that they're really correct. But it's not so bad. I think I could get used to this. Julian was late. So, so, I mean, we played around, when we started, we played around with sort of the basics of matching. And what I wanted to do now is I wanted to apply it to a tiny AST optimizer, because ASTs are supposed to be the perfect application for the new features, and so I wanted to use it for a feature that where it actually nicely applies. Right. So Julian says, wouldn't you want to sort of rewrite addition in associative ways, push all the constants to the end, and then optimize those? You're saying, yeah, we can try that. I mean, we can sort of that. I mean, there's definitely a problem with our approach here. I mean, I've just added cases that I could think of to figure out how the syntax works. But if we want to do this systematically, then we would really have to think about all kinds of complicated little local patterns that we need to rewrite, and how do we know that we have them all, right? That's kind of one problem. And then indeed, usually what you do is you sort of you normalize your trees. That means you do some local rewrites that pushes constants always to the right, for example, and you make sure that your trees are right leaning too, because otherwise you have other problems. And then in the end, you should sort of find your constants at the bottom to the right, and then you can work your way up from there. You can definitely do that. Maybe we can try that. Maybe we can try and see that. So what we want to do is, if we have something like a const plus a, we want to rewrite it to a plus const, because consts are supposed to go to the right. Const 5a, and we want to make sure that actually those asserts are annoying. I mean, in some sense, I want to write these asserts as patterns, right? So I want to say match res case. What I want is add a variable a const for, and then pass case underscore x assert 0 x or something. Not sure whether that works. Let me try. Why is x 4? I don't get that. I mean, I would expect that x is now res, right? Let me put a PB here. Why is res 4? Okay, that means we have an actual bug. That's good too. So this gets turned into 4 for some reason. Okay, I've wanted to try that anyway. Does the debugger work with? How does the debugger work here? Like if we step through matching, does it do the right thing, or does it just? Right. So if I step in here, okay. First the inits. Annoying. So now I'm in the match. So x is an add, and the left is a const, and the right is a variable, right? So let's try. We try to match it against this. This shouldn't work. This also shouldn't work. Shouldn't work. Shouldn't work. Ah ha ha ha. Who can see it? We've already managed to run into the feature that I said I didn't like. So x is now 4. Why? Because remember that what we're matching here is add const for and a variable, and that means we try to match this case here And then we managed to match the first part, and while doing so, we've overridden the x here, right? Because this part matches. It is a const, and then only the second part doesn't match. And so we failed the first pattern, but we managed to change the value of x. And so the fact that I have a return x here is actually a bug. So I think maybe this should be, I mean, I don't know. They will probably never agree to make this a syntax error. Maybe it should be a syntax warning that you're using names in your patterns that, I mean, at least the one that you're matching against, that sounds a little bit weird. I mean, it definitely feels like a bit of a foot gun here. And then here. Right. So, oops. Right. And now, okay, we failed. Our assert failed. Why did it fail? Because we didn't change the order of things yet, right? By the way, something that I also don't completely understand yet is what happens if none of the cases match. Simply nothing. Okay, we fall through. Okay, fair enough. That means we could have written this like so as well, right? Because all the cases return. Okay, so in order to change the order, we want a case like that, y, and then we return add of y and const x. That's the normalization step that Julian was kind of thinking about. I still have the PDB somewhere. Here. Cool. Right. Yes, so I don't want to, I mean, unless somebody really wants another case, I don't want to push it that much further, because, I mean, as I said, we would have to, I mean, real compilers really have hundreds and hundreds of these cases, and I'm not really sure we learn a lot more. I think one of the things we learned is that the fact that that the partial matches can really change your names is a little bit, feels a little bit weird. That's certainly, I mean, to me that's certainly a bit of a misfeature. I understand that sort of not doing that would be hard. I mean, they would probably have to compile match statements against even more complicated bytecode. Though maybe I'm not sure. Maybe not. Right. And then, yeah, I mean, my other takeaway is really you get this very dense code and you need to study every case, which, yeah, maybe that's good, maybe that's not good. Is there any other case that somebody wants added? Or any other experiments that you want me to run? Let's add one unary operation at least. Like neg or something. No, we don't need that. Right. same kind of stuff. Yeah, no, wait, I want neg 1, and the result is supposed to be a const and rest of value. Let me actually try to use a match statement for here again. It doesn't really feel that natural because you need these 1 to 5 lines, but I mean, yeah. I suppose what I really should do is, I mean, it's kind of funny that this works, right? And this complicated thing works, but this wouldn't work because we didn't add any equal operators, right? So this one doesn't work because the two instances aren't identical, so that means they're not equal by default. But this doesn't work. So this does work. So that we see that pattern matching is really, ignores the fact that there isn't actually an equality here. This really is not a call to the constructor. It's really a pattern that says, I want an instance that looks like this, but it's not at all the same thing. I mean, I think that's the other piece of critique of the whole feature, is that this looks like a call to the constructor, but it's something entirely different than the actual call to the constructor down here, right? Yeah, I should define an equal. I suppose that means do data classes give you an equal? I think they do. Actually, maybe I should actually switch to data classes. No, wait. How does it work again? Where do they live? I think I've never used them. They're supposed to be good. Yeah. I do it. Right. From data classes, import data class. So then afterwards I'm supposed to be able to write this, right? And then I can say this is a data class, and I would say left base, right base, and then I don't need any of that. That's the theory, correct? And then we have const. Wait, did I add? Yeah, I did. Data class const value call an object, and I don't need any of that. Let's see whether that theory works. Okay, thank you. I need to use Joachim says I need to use the decorator for each subclass, so let me do that. Chunk. Let's see whether the tests still pass. Right, okay, we're back at trying to do this test here, right? And what we actually want to write is this, and that means we need okay, I admit that this looks nice. Right, and while we're at it, the data class name const. It does look nice. Julian says he's 32% serious with saying that we need RPython adders. I'm actually 100% serious with that. Right, and now we get nice wrappers too. Amazing. Right. Oh wait, no. Right, because the optimization isn't there yet. Okay, so that means we need to add some neg cases. Right. Wow. Why? The test is wrong. I think the test is simply wrong. Yes. Right. Cool. Okay, what else is there? Okay. Neg of x, return x. No, there's another neg missing. Don't nag me. And we want right. Let's try this. Yeah, I did forget this minus indeed. Okay, this one doesn't work, and then we need to. Oh, nice, excellent. So here we see the amazing syntax error that CPython 3.10 has copied from PyPy. That's really good. Actually, I get this error quite regularly with when using PyPy for development. I'm always happy to see it because it does happen quite regularly. So this thing is never closed, and that means I need one here. I don't think I've ever been this happy to see an error before. Cool. Right. Actually, we're not recursing. I mean, this is really a toy implementation. We're not recursing correctly at all yet. I mean, what happens? Neg const, right? Because I think this is really not working. Is it? Oh no, it is. It might be. Oops. 5. Right. No, it is. That should be working. Right. It can live in the same test. Oh, again. Okay. Good. Cool. So one or two more. Because if you have something like opt sub variable x you should write a parser. Doing this is really annoying. Neg variable y. We want this normalized to we want to normalize this to add variable x variable y, right? X minus y should be x plus y. Cool, we're getting the hang of this. I mean, I'm not really sure it scales, right? Does this feature really scale? does the feature really scale to pages and pages of these patterns? Can you still figure out what's going on then? So there's a question by EW Joachim. I don't understand why the neg const thing worked, except if you change the order in the match case, and I missed that. No, I didn't. It matches. I mean, I think yeah, but this rule doesn't match neg const because we are starting at the top level. We don't really recurse into the tree at all here, right? And maybe we should. I mean, let's actually try to. I've been thinking about that too. Maybe we need to recurse somehow, right? What I think the question is, what happens in such a case? We have an operation at the top level that we cannot optimize, like a neg or even an add variable x, and then in there we have something that we can optimize, another add const x, const 5, const 2, right? And then we want to turn that into somehow into res equal add variable x const 17, right? But we don't currently. Right now this really doesn't work. And no, yeah, I actually, so somebody says, EW Joachim says that's going to be fun, but it's not fun. I have actually no idea how to achieve this. Does it mean that, okay, what does it mean? So let's group the things, right? Here are the add cases. Neg, and then maybe I should move this to the subcases here. Does it mean, oops, what did I do? Does it mean that at the end of all of these cases, I really need to have a recursive one? So I need to say case add x and y. That's kind of a fallback case because it matches any add. And then what? What do I do here? Return add of opt x, opt y. Is that enough? I don't think it's enough. I mean, that will certainly fix the case we have right now. Except that I wrote A's somewhere. Yeah, Julian says it's not fully general because the last thing in X may optimize out with the first thing in Y. That's absolutely right. I'm sure we can. Let's actually try to. Write a case that this first case passes. But then what happens if we have a more complicated case that says this is also a constant? Right. We want to turn this into the constant 0. I don't think we can. Right. And we recurse into this part and we optimize it to 17, but then we need to restart the optimization of this thing. But we should not always do that because otherwise we will run into a potential recursion. Yes, yeah. I mean, we can definitely try it. I mean, you can definitely try to have some kind of fixed point architecture which is I'm not. I think we're not really systematic enough about this, but I'm not sure I want to be tonight. I think I think I'm going to. I mean, I already said that this will be a relatively short stream. I'm going to finish soonish, because I mean, I kind of achieved what I wanted to achieve here, which is to get a feeling for the general, how does it work and how does it feel, and I agree with all the comments in the chat that if we want to be serious about it, we need to have a much more principled approach and really think about, we have this complicated tree, what does it mean? How can we make sure that we really get all the reorderings that we can use to remove all the constant foldings that are possible and so on. And that's complicated. I mean, real compilers do very complicated things here. And I mean, also we're doing there are many things that we would definitely also want to have. For example, right now what we don't have at all is something that discovers that we have repeated expressions in our tree. I mean, what we would like somehow is we would like to see that, oh, you have an x plus y here and an x plus y here, and we want to reuse the result of the two. And I mean, in some way that would be a pretty fundamental optimization that we don't have at this point, and I'm not really sure it fits into the pattern either. So yeah, I think I'm going to wrap up in a couple of minutes. Right. Yeah. Okay. Let's use the remaining minutes to do some more qualitative discussion here. Indeed, one question is, if we switch to a real architecture, can we still use the feature, right? Can we still does it make sense to have this list of patterns then in the more full architecture of such a small optimizer? And I'm not really sure about that. I mean, I didn't really plan any of this. I just started writing, and Julian says we can get out of the problem by using. What do you mean by shotgun out one term in the tree? I don't understand the suggestion, I fear. Right. Yeah, I mean, I think my summary is, I kind of like it. It gives you very concise code. It's very dense, and it looks like Prolog, which I like. So it's good. That's good for me. It's kind of an anti-Prolog, because in Prolog the patterns would have sort of opposite upper lowercase usage. Right. Okay. Sorry. Julian says his suggestion was sarcasm. I'm not so hot on the fact that failed patterns can give you bindings left over. I think that's a bit of a misfeature, though I understand that it might be very annoying to not produce them. And yeah, the real question is, if you scale this up to a proper, real big thing, can you still use match? I mean, I'm not quite sure. I mean, the other thing that really also quite interested me is, I mean, in the end we got rid of having to do that by using data classes, but I still think there's a very useful usage for these very localized match statements with exactly one statement, right? I mean, sometimes I really want to extract fields out of several complicated deep levels of my tree data structure, and it feels like match could be nice for that sometimes. even though it feels a little bit overkill because it really gives you these let's say at least 5 lines, and yeah. Right, so sorry, Cliff Kubely says, is this the match feature of Python 3.10? Yeah, it is. This is the match feature that got merged into the 3.10 branch yesterday, I think, and we've been playing around with it. Yeah. Any other qualitative comments? Yeah, I really wonder how. I mean, I think I need to play around with it a lot more to find out whether I like the feature or not. But I really wonder whether it scales. Like if you have 4 screenfuls of these cases, do you really still wanna? I mean, do you want to do that or not? Or would you rather sort of? I mean, maybe you split it up. Maybe you really just have one match statements for all the ads and one for all the subs and one for the neck. Can you have a tuple here? I suppose you can, right? Can you say match 1, 2 case x, y, print x, y? Yeah, right. Okay. With that, I think I'm done. Sorry that it was a slightly shorter stream than usual, but I had a really exhausting week, so I'm going to call it a day much sooner than usual. And yeah, the plan is to have another stream next Saturday at the same time. Thanks to all the new people for joining us today. I had quite a bit of fun, even though we're only left with this small sketch. Are people interested? Should I like put that into a gist? Are people interested in that thing, or should I just kill the file? I can do that. My Twitter handle EW Joachim says he would like to follow me on Twitter, and it's this. Right. Yeah, thanks for joining us tonight. You had great comments, and I thought it was a really good discussion tonight. I really enjoyed that. So thanks everybody for that. And here's the gist link. Right. And oops, no, that's my email. With that, I'm done. Thanks everybody, and hopefully see you all again next Saturday. Bye.